I am Kashnath from AS Designers Limited. I am very happy. Majority of participants are our customers, and it's a privilege for me also to share our expertise knowledge with you people, where you can benefit to produce more or improve quality, reduce cycle time, cost, and empower your juniors to make operational ready. So now we have a 3 hours today and tomorrow 3 hours. And now how effectively we can utilize these 6 hours is also a task. And really you all get benefit out of our interaction of this 6 hours. And later you can go and implement in your shop floor. For doing these activities, I divided this total 6 hours into 3 segments. The one is you spend 1/3 of time go towards approach. See, now the cycle time is the one, and cost is the one, safety, then quality of component, then I think already everybody know the cost, quality, and delivery. These are the one task. Now in this case, first we'll spend a time on 1/3 of time on approach. That means why we have to do that and how we can do it. What is the best method? Then how we can collaborate inside your organization, and how you can collaborate, organize inside your organization to do this much better. The second one is we focus on turning center applications. There again, it's a 4 category. One is general turning. What will be your view on general turning? General turning means external turning and internal turning. It may be long turning, it may be short turning, the check held, or maybe a tailstock between tailstock or something like that. That's on general turning. In general turning, what are the challenges normally we face, and what are the hidden things it will affect on your tool life, it will affect on your the quality, and it will disturb more and more supervisors to intervene again and again. Such things we do in a general turning. The same way again grooving, ID, OD, and face groove, and same way on threading. Challenging. The threading is also a big challenging in many industries of different size of threads. Till you get better quality, till you get gauge answering, you will be losing component, because every component threading is normally a final operation, correct? No, either it's OD or a ID thread or anything. It's a final operation, and if you don't get component okay at the end, that means you lose many things: material, the process cost, and everything. Then how to look at that threading, and then again drilling. That means in turning you look at general turning, grooving, threading, and drilling with small tips, because most of the things already you are aware, but maybe certain things written beyond I am also not knowing, or you are also not knowing, and whatever I am having expertise I will share with you. Then you can take an audit from your factory, and I want to see all the participants to go back and start yourself as an auditor inside your factory to a machining audit. Normally you are all aware you have so many audits, ISO, environmental, all those things, but generally if you see in our ISO, nobody audit that is this program is perfectly okay for this component. Is it optimized program? Is it a best program? Correct? No, normally that kind of questions won't come. It left to the programmer, it left to the setter and what they run, but they do great job. But still, if you can bring it to that platform, we can bring a big change, because the same thing 1/3 time you are going to spend on VMC and HMC applications, because application wise VMC, HMC is same. Maybe it's horizontal and one is vertical. The only capacity will be different. But there again, you can say the face milling category, side mill category, side and face mill category, the drill, tap, spot face, or internal grooves, external grooves, or spigot turning, or whatever it may be. If you can see that these are the challenges, if you can, maybe the same kind of things may not be there in every company, but whatever you collect data, you can make a big change. Okay, these are the 3 segments. I'm going to divide into 3. One is for approach, one is for turning, one is for machining center. The small awareness things to you. See, this session is basically a very simple course with 8-10 slides, not more than that. And afterwards, you'll have a more small case studies and interactions. And this approach will give you 80% of the method, what you can do after reaching your factory back. I think maybe tomorrow, day after, or something like that. It will help you. And even beginning itself, I can tell you very simple way. if any company is having a 10 machine or a 20 machine or a 30 or a 40 machines, for example, if you take, I am having 20 machines in my factory, 10 turning centers and 10 VMC, and 10 turning centers are running with some number of tools. Even worst case, you take all machines are running with 8 tools, for example, 8 station turret, and 8 into 10 is any given time, 80 tools are running in your organization. Then what is the average cycle time? Maybe 3 minutes. In every 3 minutes, 80 tools are running. Now, do you have a data of that 80 tools, what it is doing? What type of tools you're using, what type of method approach you are doing it, then is the time is perfectly okay. Suppose somewhere else I'm doing a bore for a depth of 50 mm, I cannot reduce that 50 to 45, impossible. The only thing is there any optimum way I can do it faster, that bore, that's all. And some places where your other areas, you can do a lot of things in a rough turning or other applications. So you can see that, how we can see that. See, this is very simple. If you have 10 machine, you collect that 80 data, do daily 2 or 1 or 5 numbers of study. Within, say, if you said daily 5, 80 means at least within some 10, 15 days, you'll come to some conclusion. Yes, I can deploy all these things horizontally across my factory and get optimum results. The next year, you can see this. Our main objective in this session is our approach towards is the manufacturing component as per drawing at a lesser lead time and reduce cost. See, these are all actionable. Lesser lead time means, I think some people are mentioned NPD. How fast I can develop the component. Normally, whenever you get a new drawing for a development, what happens? You have to study the drawing, list all the critical dimensions, GD&Ts, then how I can hold it, where I can hold it, then how much I have to give finishing allowance. All those things will take a time. And next, you have to select the tools, right tools for that. Sometimes you'll have an undercut in the corner, sometimes you'll have an undercut in the OD, and there will be some critical things will be there, either bore size or something like that. See, that time, any wrong selection leads to your lead time increasing. Or the way of you write program, and whether you write program on the machine or you do offline or you use CAD CAM, or do you have any second level, third level of team to evaluate somebody's program. So I write the program and voluntarily I will give to somebody else to evaluate, and it will go to the second. That means if there is an approval comes from 3 teams, yes, this is the best way of cutting and no error in the program, I can put it on the machine, then close the door and run it. There's the possibilities. Actually, these are all exercise we did in many companies. We got a very good improvement. That means your total lead time of developing new component has come down to 50% or 60%. Even some company claim, now I take a decision in 1/20, that means 1/3 of a time, the complete action plan. See, this is where it helps you to enhance your business, because everybody's time is important for decision making and improvement. Then same time, you are reducing cost. Suppose 10 people are taking some man days to conclude something. If they take off time in that, that means off time you are saved. That means same person can do something else and do some improvement. See, they're all actionable points. Lesser lead time, reduce cost. And again, the essential to ensure this is competitive production. Today, the world, you know, the one is cost is the competition. The another one is the quality is the competition. And another one is how you keep your equipments, performance and longevity of your products. That means the machineries, or maybe whatever you produce component, how does it perform in its own application? See, these are all sensitive matters actually. Basically, how sensitive you are, that much your focus will be there on all these activities. So our objective is to look at the lesser lead time and the reduced cost. That means the time and the cost. These are all very, very important. The purpose is competitive world, and again, quality and cost. Next is the definitions is non-productive. I think you all know that waiting for material, tool, machinery, electricity is not there, and decision maker is leave or they are in meeting, and inspection is delayed, operator is absent, is not healthy, something like that. Then again, breakdown. See, these are all normal things. You know, you can add more point to this. The only thing is how to overcome. You cannot make it zero. Something will happen, but how to overcome fast, that is more important. And next is contribution to idle times, definitions, and this idle time, the frequent setup change, frequent offset corrections, and the changes in machining process, longer inspection time, proper planning. These are all things you know that. And certain machines you'll have, like, no, in AS you are giving machines with the BTP turret or whatever it may be. It has its own indexing time, but it has an advantage also. But in Mazak machine or some other machines, it index fast, but it has its own technology, its own cost again. So now I cannot change that. It will take its time. It will take. Suppose in our machine, if you give 3000 RPM, it will take 2 seconds to reach. But some machine takes 1.5 second. That has a different technology. For that, people have to pay for that. So now, whether it is really required, what is happening, that you have to see that these are all what is that, factors for adding to those things. Okay, we're discussing on this the mass production and batch production. So mass production is small inefficiencies, how we can eliminate it. Then another one is the batch production. Next is what is that we can do to produce more. One is you can add more machine. Definitely there is a scope to expand your business, make a different unit and all. I will not deny on that, because you have 10 machine, next year you can have 20 machine, because that much business you are adding. And I'm talking about what you can do in existing itself. Suppose I'm producing 50,000 per month component or 20,000 per month. Now I want to produce 25,000. Then 25,000 means you are supposed to have 25% machine. Instead of 10 machines, you have to add 2 more machines. The first scope is don't add the machine and try to find out, is there any improvement is possible. That means I can remove something, unwanted things, and make it in a better way. I can produce that 5,000 extra component. So this is where the choice should be: effective utilization of equipment, remove unwanted things, then resequence your operation if required, and maybe invest and instead of investing 25-30 lakh rupees machine, invest on some cutting tool. Okay, and best tools, maybe it may cost 5,000, 10,000, 20,000, and it can give you a different advantage. Then you can have a target. After all this, now you are coming to target setting. These are approach actually. In our organization, you have 20 machine, you have 30 machine, you have collected data of each machine wise. Now you have a bill of operation. N1, this is the tool. This is the speed feed, and this is the cycle time for N1. N2, this is the tool. This is the cycle time. Now you can fix the scope. Suppose you're doing some drilling for blind hole tapping. The drill has to go 20 mm deep. I cannot reduce anything there. It has to go, no other way. Suppose if you have 20 holes, it is better to use the better tools which can run at higher cutting speeds and feed rate, so that I can reduce cycle time. Suppose you have only 2 tools, 2 holes, or only 1 hole. Then what do you do? Don't use costly tools there, no use, because 1 hole for 20 mm deep, it may take maybe 12 seconds. If you use costly tool, it may take 8 seconds. But instead of 600 rupee tool, use 6,000 rupees tool. Unnecessarily, you are increasing your inventory. It's not required actually, basically. See, that is where you have to play smart sometime. Then where I need that. Suppose I want to walk just 100 meters. The walking is more efficient way, 100 meters. But no, I'll go by car. Then go to car parking, start the car, take the car, go there. It's a sometimes nuisance actually, correct? No? So now here you can fix your targets on all those things where I can do. I will have some 10% enhancement in a shop floor efficiency, then machine life. That means so far in last year, machines are breakdown so many times. I'm going to save it, then improve manpower efficiency, then improve tool life, then reduce tool breakages. Say, last year, maybe around 50 TNMG insets are broken, 20 drills are broken, 18 taps are broken, something U drill is broken, something is happened. See, now all those things you should have a data. Then you say this year, all these things will be reduced by 90%. By using efficiently. Then accident should never happen. Then reduce rejection, because the rejection is the very important point actually here. Anything you reject, suppose a 3 kg steel rejects, what will happen? What are you going to do? It's a scrap basically, correct? No? Now to bring steel to your shop floor, it already added pollution. Now further you are going to add the pollution because of our small mistakes. This I'll scroll through. See, just quickly I will show this how the audit is been done as a team here. You can see this is some of our Bosch customer. And I made a team of the Bosch customer and our customer, that means their vendor all together. There are some problem solving issue and producing more. And complaints have been listed. Then we deliberated all this like a presentation. Then finally we were concluded in 2 days of this machining audit. So now the result what we got is optimum cycle time. But how we did, I will show you the next this one. Because certain things, information we cannot share. So now here you can see this liner parts where customer was facing problem with the field issues. That means when the liner was pressed into the cylinder, the head was breaking actually. That means the collar was breaking, cracking, something issue was there. Then finally, we have studied that and we identified the before after this corner radius, how it forms. Then we start getting perfectly 90-degree. It is basically the chilled cast iron tool cannot reach the shoulder. If it reaches, there will be tremendous force on the tool. Then the shoulder will not be perpendicular with respect to the bore center. See, that is where we found. Then instead of turning, we start doing facing near the shoulder. Then we found that shoulder. We got perfectly okay. The customer is very happy. His problem is been solved. See, this is an actual case study with the length of this is 30 or 31 dia input polish bar, the length of 225 mm length, and finally it will be turned up to this diameter of 12.7 half an inch. Then again there will be a groove here and groove, and then one more groove, and the full length there will be a threading. Complete length there will be a threading here. So now in this case, just naturally if you see, when a turning tool comes and start turning this much, okay, when a turning tool comes and start turning from here to here, suppose in case if chip is not breaking, what will happen? The chip will wind on the component, everything will push towards the collet. Then if the chips are not breaking, that will create one wall. Then there will be chances of insert breakage or chip will rub on the component. So one danger actually, because chips have to break, number one. Then another one is, if I turn full length with a 2 mm depth of cut radially, the 30 dia become 26 dia. That means your LBD ratio increases. You got idea, no? That means your LBD ratio increases, then component will become weaker and weaker. But as you take next cut, the further LBD ratio, the 26 become 22 in the second cut. Then LBD ratio become bigger again. So now in this case, what will happen? One is chip and another one is LBD ratio. These two are the issue in this. Now we can see here what we have taken action for this to resolve first chip breakage and the tool issues. So now same component, we divided the segment into first two stages. The tool will turn up to here. It will come back and do this. Then again, next it will turn this portion. That means that component will be stronger. Only this much will be turned and next it will be turned. The next case we took, same length of 220 mm, you are divided into 4 segments. That means first 55 mm, second 55 mm, third 55 mm, last step again. The advantage is I want to keep diameter as it is. See now the total rapid time, it may be around 5-6 seconds, the retraction and going back and other things. But that continuous running, it was having a fix. That means I had to use only 0.25 minutes, 0.25 feet rate, 0.3 means 0.3, and again chip winding. Now in this case, what has happened when I did this, the first set of cutting from here to here, okay, it was going with maybe instead of 2 mm depth of cut, I go 1.5 mm depth of cut. Instead of 0.3 feet rate, I go 0.4 feet rate. No issues. The next cut, instead of 1.5, I go 1.8, but I will use 0.35 feet rate. Next, instead of 1.75, I will go 2.2 depth of cut. Then near the check, the machine is capable of taking 3 mm depth of cut or 3.5. I can take it, no issues for me. And because of the shorter length, the chip collection will be less. There will not be much problem there. See, this is where it is saved the chip breaking by one tool. See, this is one tool is doing a step activity. The second action you have taken in this case, instead of one tool, we put 2 tools into the turret. One tool will come and do this portion. Another tool will come and do this portion. Like that, 4 portion, A, B, C, D. The A is done by tool number 1. B is done by tool number 2 because the total cycle time is very big and tool indexing time is hardly 1.5 seconds. So now I am ready to lose 1.5 seconds for tool indexing, but still I can save time somewhere else. So now in this case, what we did, we used 2 tools. One tool will come and do and go back. Another tool will come and do B portion. Then first tool will again come and do the C portion. Then second tool will come again and come to the D portion. So what happened in this case, the total life of the insert is being shared with 2 edges. So now the intervention of changing insert is also changed, number 1, and safety is increased. See, this is where we have changed this method. And here what happened? The less tool contact time, increased tool life, subsequent step towards headstock of machining at higher parameters. I think somebody asked question here, minimum cycle time and maximum cutting parameters. See, normally in any machining, the maximum cutting parameters can be used where your contact time is less. If your contact time is more, you cannot use maximum cutting speeds because the tool will go rupture fast and life can go. See, that's where here you can shorten your contact time and use maximum cutting parameters. See, because suppose your parameters are increased by 30%, okay, the time is say saving around big cycle time, but your tool change time is very short. Better you can change number of tools, no problem, because ultimately you are sharing the tool life and you're utilizing it.